Let's see. Dr. Edwin Hwu has worked on with hacking those Blu-ray heads to do atomic imaging. This is hacking commercial hardware to do serious science to help keep hardcore scientific research on a budget. So with that in mind, I would like you to join me in welcoming to the Hackaday Europe stage, Dr. Edwin Hwu.
It's my pleasure to share my research, and basically it's hardware hacking, especially consumer products. And I'm associate professor in D2 health tech, and I think I will show you my journey of hardware hacking. So originally I'm from Taiwan, and I have a mechanical engineering background. And I work with the German Metrology Institute for Atomic Resolution Imaging. That's a hardcore metrology. And also nano X-ray microscope with the Brookhaven National Lab. And also high throughput bioimaging in Japan. And I collaborate with the Danish Institute at the time. And later I moved to Denmark and to work full time on real-time cell culture, and then also the skin diagnostics, okay, and also 3D printing. But actually, I'm also doing the solar panel characterization. You think, what? Why my research feels so wide? But they all point to a central point. That's a hardware hacking. And I will show you why. So the first, I would like to define what the hack. My definition is to make use of surrounding consumer product for different, even crazy applications. So using hardware hacking might seem like this is kind of a miracle and it's not easy to duplicate. But actually, everyone, even without hardware hacking skill, you can just download the app on your iPhone. And this could be a digital scale. You see the calibration curve on the right is quite linear. So it's quite useful in your kitchen. And hardware hacking saves lives. I think in the COVID time, there are genius Italian engineer. They just grab the screwdriver mask and hook it up to the other system. They can save a lot of lives in hours. So normally, those kind of ventilator, you need to wait for months to arrive. So at that time, really saved a lot of lives. And here's my experience about hardware hacking during the COVID time. So at that time, I was a consultant of a biotech company, and they need to ramp up the production of a COVID test. And because at that time, everyone needs to be tested, right? 3 times a day, even more. So we have many biomedical sample, and we need to agitate it because we don't want it to aggregate while we are producing the test. And we need to shake the 6 vials, so in the normal vibrator in the lab cannot work. We need the heavy-duty one. This one can generate 19,000 RPM vibration per minute. But you know, 2020, at that time, the shipping is in a mess. So we can only get it like 6 months later. So at that time, we are rushing to build a production line, and we need a vibration. So where can we get strong vibration? And then I think, we go from another industry. Don't underestimate this toy. It gives you 17,000 vibrations per minute. And we have plenty of them in Europe, so I order it and arrive 2 days later. So like this. And then we open it. Inside, there's a very strong motor and the vibrator, and at the same in the one set. So I disassemble that. I put in our agitation platform, and fits perfectly, powered by battery. It worked. So the production line, you can see the very strange humming sound in the surrounding the vial, because this the toy provides some more feature. So you have a different kind of sequence, and I believe they mix the reagent better. Okay, so this is my hack during the COVID. So here I would like to show you how the hack, because I'm in the academia, so I need to show those boring professors why I'm doing this, how I'm doing this. So the first is disassemble, and we learn, and we have a new idea, and then we put it back. So I think this is the fun process. I love it. It's really satisfying to see how they make the design perfectly. But when I was a kid, I really cannot put the very expensive camcorder back. And, you know, the Asian mom is something like this. So I'm pretty happy that my mom didn't beat me to death. I cannot continue. And then if you are not like handy people, there are some YouTubers like this one, Jerry. He really can disassemble the consumer hardware like this projector and show you each component and put it back and still working. That's amazing. So why the hack? I think when you see this is a smartphone, but for me, I see a treasure box, because we have optical sensors, we have a power unit, we have actuators, we have a control unit, we have display unit. So they are all geniusly designed and fit together. And one thing is important, is that if we only produce one iPhone or one high-end smartphone, only one CPU, only one retina display, only one super high-resolution camera, it will be easily cost more than 3 million euro, because you only produce one. And unfortunately, fortunately, that the smartphone we sold like really 2.2 billion units. So if we use this curve, the unit cost will dramatically drop down if we produce in super high volume. So that gives us many benefits. So I show you the benefits. The first one is a high performance, and the second is a low cost. Here's an example. So because I work with the Metrology Institute, so normally they like to do the atomic resolution imaging. You need to have a PC and control the DA converter, and we need a high voltage amplifier to drive the magic stone. This is a kind of piezoelectric material. You provide voltage, it gives you a little bit movement. And it's very expensive. And later, I found out that this is the personal alarm. Normally, you buy for your kids. When something bad happens, just pull the plug right here, and it generates a loud noise. And the source is the piezoelectric speaker. So this is a copper thin film, and the red part is the piezoelectric material. So I use the piezo-buzzer, 5 pieces, and if you buy 5, it's only 0.1 euro, and it doesn't need a high voltage amplifier, and we put it together, we can be the scanner. So it has, you can see it on the top. The traditional scanner, it has a distortion, but at the bottom, our low-cost buzzer scanner has a higher linearity than the traditional one. So this is the buzzer. Thank you. So this is buzzer scanner, and not so big, and low voltage is safe. And this is graphite surface, and you can see the cross-section. This is the 0.36 nanometers, it's a 1 carbon atom high. So we can reach atomic resolution with this super low-cost speaker. And then we check this too, and we can also combine new research. So I show you this is a lab on a disk. So this technology will combine the tubing, will combine the switching, and centrifuge, metering, and the mixing. So this is how it works. So we put the liquid or the assessment liquid on the disk. So we can see what's rotating, use the centrifugal force for all the operations. But you may wonder, why is it rotating? We can still see the liquid moving? Because there's one technology called it strobe photography. So this photography needs very precise synchronization. You can see this is a CCD camera, and this is for the flashlight, and this is the motor. So we need to synchronize that in very high resolution. So then we can take the photo like the video before. So we need to adjust the angle precisely with a precise control. So if your camera shutter matches the rotation, you will see something like this. This is not glitch of metrics. This is when your camera 60 frames per second match the 60 rotation per second. Then you see this. Then we can observe what's happened. So this kind of system combining the electronics, programming, optics, takes like PhD like more than 3 months. And we have this system in our basement. But you know, this system has some drawback because it only takes one photo, one revolution. So you don't know what happened right here, right here, right here. Because it's the frames per second of the imaging resolution, temporal resolution is correlated to the disk rotation. So you cannot see the fast movement in low rotation frequency right here. This is a question mark. And you know, I'm lazy, so I try different methods. I just buy the spy camera and wireless power, and then put it together so the camera can rotate together with the disk. So it takes only 1 week for master student and lower cost. So this is the slow motion. You see the camera is rotating together with the disk, and we can see the real-time image wirelessly without any programming because the spy camera provides a very nice mobile app already. So we can observe the centrifuge process on the disk. And then we have another benefit because the camera is following the feature. So we have a fixed imaging temporal resolution, so 30 frames per second, so no matter which angle you are. So we can observe something like this. The two-color mixing happen rapidly and cannot be captured by traditional expensive system. So that's the new paper. And then combining the object lens of a Blu-ray head, we can make the microscope on the disk rotating. So this is one video I made for a conference. So it's a cell culture. We need to put the medium inside and also the waste outside. So traditional way, you have a pump and make the big bottles and big microscopes. It's really complicated, yeah. So we combine wireless power and the microscope, and then become like this. And the PhD students really thank me because they can just put the system inside the incubation chamber. They can monitor the cell from home. Yeah, that's the old joke. Okay, so then what about we combine the quadrocopter? So what can we do? Any idea? Okay, I show you. So this It's an all-in-one power lip-on disc system. So we don't need a big motor because we are driving the disc with a quadricopter. And we control by Arduino and also the simple Bluetooth module. And this is just a current amplifier. And why I choose drone motor? Because the lap motor is too heavy, and the DVD drive motor is too weak, and the drone motor has high performance and also low weight. So this is the size of the traditional system, and this is my system. We can take it out with the power bank, and then it will work. So this is the system I put it in, and connect it to the pad, and we can set the target frequency, and this is the actual frequency. And you can see we have a small propeller inside. So it speeds up rapidly, and we can do all the lab-on disk work in the lab or in the field. Okay, so we check we have a new research, and then we have one benefit, a shorter time to market. And this time we're hacking the Blu-ray drive or optical drive. So this is the Atomic Force Microscope. And we are using a very sharp probe to measure the surface nano-scale resolution. And normally it uses custom-made laser and also the detector. And this we call the AFM, normally called like 100 to 500,000 US dollar. Anyone use AFM before? No. And I had the idea, actually that's during my PhD time. I was wondering what about we use the DVD head to monitor the probe. And then I tried it for a while, and it worked. And we use a super cheap the DVD head. We can get atomic resolution like imaging. And this is also reported by the journal. So again, this is carbon atomic layers, and on the right-hand side, this is the DNA molecule. So we combine the scanner and the DVD head, we can do something interesting. Thanks to the LEGO Foundation, they would like to have a hands-on nanotechnology education. So we cannot touch the very expensive AFM, but we can make our own. So I just use these chains to combine the buzzer scanner, the optical pickup pad, and also the circuit board as a structure, and Arduino as the controller. And to make the world's first Arduino-controlled atomic force microscope. And then it can be assembled by the students, and they can get the nano-scale imaging by themselves. So it's a kind of 100-volt cheaper than a traditional system, and we can much more students. They can really do hands-on education. So also Nature Nanotech, they introduced this technology, and they became a startup company. And only within 6 months. You know what? Because we are using the PCB as a structure, and we are using ready-made DVD head, so they don't have a complicated production line. So they just put that together, and the user, they can assemble by themselves. And another hacking is using the Blu-ray head on the left-hand side to detect the nanoparticles. And this is becoming a startup company and between Denmark and Taiwan. And also we passed the in vitro diagnostic device regulatory within 4 years. That's a record breaking at that time. So this is how it works.
Is powered by a patented technology called immunomagnetic assay, IMA. Blood flows into microfluidic channels where plasma is separated from the red blood cells through a micro.
So basically, this is lab on this technology developed in our lab and become the startup company. So for the interest of time, I don't play them all.
The mixture.
And this development got the top 3 nominations in European Patent Office.
Used to detect target viruses such as dengue fever, Zika, or COVID. Essentially, it uses a modified Blu-ray optical pickup to detect light that has been scattered by magnetic nanoparticles. This scattered light can tell us whether any target virus is present and how much of it there is. It's accurate, it's inexpensive, it's lightweight. And this is important in many remote parts of the world where people do not have easy access to high-quality medical care. The blue box brings high-quality medical diagnoses directly to them.
I really love the optical storage technology because they built something amazing. I can use that not only for this, also for other applications. So short-time market check. So what the heck is going on now? The first thing, again, the Blu-ray head, we can also use that to characterize the optically with solar panels. So we use a laser beam-induced current to test the solar panel, and we can get the similar resolution if we use a scanning electron microscope. So that's my collaboration with the UK university. And also, we can directly use the head and the laser light to measure the biomedical sample, and we can get higher contrast than the high-end optical microscope. And that was surprising. And then we are using Blu-ray head for high-resolution 3D printing as well. So anyone like injection? No? Okay, I have one needle for you. I think basically no one like it. And that's why we have a special kind of a needle. We call it micro needle. You can barely see with your eyes. So this is kind of needle we just cast the drug on the needle shape. So you can see we just push it inside the skin, but it doesn't disturb your nerve underneath. So to cast the needle, we need to have a mold. To print the mold, we need to use a 3D printer. So you can see this is the scale, and from nanometer to millimeter to micron. And this is a 3D printer on the market. So we found out that if we like to make this microneedle mold, we need to have two printers. This high volume, low resolution printer can print the bottom, and this one can print the tip. But they are both super expensive, so we cannot afford it. So we decided to build ourselves. So there's a gap right there. And fortunately, the Xbox, they have a nice optics, and we can use that. It's cost less than $5 if you buy 1,000. So it's a high resolution, like a research grade microscope. So we just move the head, like X, Y, and Z, like this, and then we can print the photopolymer. Here, this is the Blu-ray head, and we just print inside of that. So you can see we can get nano-scale resolution. We can get microstructures and large volume. So when we publish our paper, it makes some noise in the 3D printing field because nobody think about that the Xbox in the living room collecting dust, it can do something like this. So we have a 3D printer built up, and we think central with the Blu-ray head, and made in Taiwan. I machined it. It's low price and good quality, and we can print Eiffel Tower. So you can see this is 1 millimeter, and this is a sound feature inside, and we can also print different material at this scale. And this we also print. The Notre Dame is burned a few years ago. We reconstruct this in micro scale, so we can realize all these small details. And then we can print the mold for the microneedle. And here you can see it's the tip. It's a kind of 8 micron. It sounds not so nice, but if you compare the similar price printer, this is their result. So we are 10 times better. 80. So here we can even print the channel inside the needle. So for example, insulin delivery. So we have this very small channel, and again, compared with the traditional system, they can only print like 10 or more times a larger the channel. So we can have 4 channels inside one needle. So this is a rough comparison. Okay, and then we have another 3D printer developed. Why? Because the previous one is a little bit slow. If we need to print the Notre Dame, it only takes 22 hours. And you can see the throughput and the resolution. So here is the DOP. I think we can see lying around. It's a high throughput because it projects the image, but the resolution is not so nice. And the SLA is using laser spot scanning. A better resolution, but throughput becomes lower. And this is 2-photon polymerization. It's super expensive and super high resolution and ultra slow. So what about, because they are all using raster scanning. They are scanning the laser light. So if we have some system can get a relatively good throughput and high resolution, and then again, optical drive. So it can rotate like 10,000 RPM, and the linear speed is 61 meters per second. So I developed a system. This is an ordinary Blu-ray drive, and we just use this drive to spin code the photopolymer. So we can code really fine, high-resolution layer, and then we put another head to solidify this layer. So this is how we spin code it. And we can spin code like in nano-scale thickness. And this is we are also utilizing the tracking mechanism of the Blu-ray system, because the disk is wobbling. And how they read data, because they just follow the wobbling. And I just utilize this mechanism to print on top side of the disk. So you can see this is the US Air Force resolution pattern, and we can also print high resolution, like the DTU logo. The diameter is less than your hair, so that's pretty small. And we also print several layers and like pyramid shape. So it's 1 million micron per second. So it's the fastest 3D printer in micro nanoscale on Earth right now. So it can have some application. I won't go into too much detail. And here I would like to talk about if we hack it right. We leverage €1 billion developed technology, and they are mass-produced and off-the-shelf. We can directly use it. And it's eco-friendly because we are not only recycle material, we recycle the technology. We don't need to reinvent the wheel. Because there's some technology already there waiting for you. So if we have a startup company, it will have a better price for customers, higher profit for the company, and easier to start up company. That's a bit that's a bit trade-off, because my PhD student stopped his study and go for startup. So sometimes it's not so good for my research. And Reddit strategic investors, for example, the disease diagnostics company, they got full investment from the Taiwanese company because no one is using the Blu-ray drive anymore. So they just all in and to get the company fly. And this is a very important part. I would like to search for the PhD student right here. If you are interested, if you are retired and you have a master's degree and you're welcome. And I made a video because I would like to hack microelectronics for next generation. Ingestible device. For example, in short, I would like to convince people swallow your Bluetooth earbud for some sensing. I'll show you.
Health tech are doing right now on the project funded by the Novo Nordisk Foundation Challenge grant titled Energy Materials for the Gut, or IMGUT. The idea was born out of a want to create next-generation ingestible microdevices that could monitor and treat gut conditions wirelessly. The project further evolved with the thought, why not harness the power of everyday gadgets? And thus, the journey began to incorporate microchips, sensors, and drug delivery systems into miniaturized pills that could sample the gastrointestinal environment and communicate with external devices. This innovative project is all about upcycling existing commercial technologies and giving them a new lease on life in the medical field. It's about creating a bridge between technology and healthcare, where one empowers the other to provide better patient care. But who is behind this ingenious idea? Meet Edwin Hwu, a hardware hacker who is supervising this project. Edwin's vision is to blend electronics and science in a way that pushes the boundaries of what's possible. He is looking for someone with an entrepreneurial spirit, a knack for tinkering with electronics, and a passion for making a difference in the world. The goal is to create a new breed of ingestible devices that can wirelessly communicate, control sensing mechanisms, sample the gut environment, and release drugs as needed. The research will delve into various consumer electronics, including wireless headsets, smart home devices, and smart watches, to find the best fit for the project's needs. This project is not just about creating something new, it's about changing the way we approach healthcare and technology. It's about thinking outside the box and using what we already have to create something groundbreaking. Now, here's where you come in. We're looking for a motivated PhD candidate who can take this project to the next level. You will be responsible for exploring, evaluating, and applying consumer microelectronics in the development of these ingestible devices. Your research will span a broad spectrum of technologies, and you'll be working in a highly creative, collaborative, and ambitious environment. This is your chance to be a part of something truly revolutionary. So, if you have a background in electrical and mechatronics engineering, a creative mind, and a passion for improving healthcare, we want to hear from you. Apply today for the PhD scholarship in repurposing microelectronics for gut sensing, delivery, and sampling devices at DTU Health Tech, and help us change the face of health technology.
Okay, actually, if you are interested, really come to me after my talk. Okay, because we got like €8 million project, and we really like to make this kind of, because gut sampling is really not easy. And you know that a gut microbiota can decide how you think, how your body shape and your healthy status, but it's super hard to get a sample inside. So we are really addressing this challenging task. And we are doing not only sampling, we are doing the sensing and harness the energy inside. You see the Bluetooth, everything on the earbud have already, right? And we also need to do the delivery and also sampling. So I think this PhD position will be really interesting and a lot of fun and challenging at the same time. And another thing is that normally I do hardware hacking academia setting. I have an issue is that I have too much funding I cannot spend because I just use super low cost consumer electronics to finish the task. So my hobby is to use a research funding to buy a PlayStation 5 or Mac, Apple Vision Pro and to test and to disassemble it and have some fun. So I think that's the benefit if you are hacking in the academic setting. And I really welcome if you are interested, just contact me. So we are going to do sensing a delivery or sensing a sampling inside the gut. And if you'd like to know more, we have summer school. If you are study PhD and you like to learn some more hacking in our group or sensors, you're welcome to attend. Or you have friends who have studied PhDs, you can recommend he or she to join. Okay, so I would like to thank our funding agencies and our very clever, bright young men, because I'm MB background and I know system integration, but I don't know much how to code, how to make electronics. I only have some ideas. So everything cannot be done without them. So thank you very much.
Thank you.